There you go. So I published a whole bunch of new stuff for chapter 14, geometry. There's a link to the activities. We're not going to do all of them, but we'll do a lot of them. There's a GeoBoard app, which is supposed to open. Oh, it opened in this screen. Interesting. I want you in a new screen, please. So if you're on a computer and you don't happen to have one of these, the GeoBoard app is kind of fun. Let's see, what else do we have here? We are going to probably start and finish activities 1, 2, 3, and 4 today. We might possibly get into, I made an activity called GeoGebra Regular Polygon Area. I might get to that today. We'll see. And interestingly, there are, I think, 5 sections in this chapter. All of this stuff is section 1. Section 1's pretty meaty. There's a lot of stuff in it, kind of like section 1 of the previous chapters. A lot of stuff in there. So we'll be on this stuff for a week before we get to move on. What else? I guess we should just jump right into it. So chapter 14 is 2 things. It's about area and it's about volume. Those are the big topics. Volume means we got to get into 3-dimensional shapes. So we're just going to play with area for a couple of sections, and then we'll jump into 3D things, and we'll start building 3D materials. So what I need for you to do is get your GeoBoard out, and before we start activity 1, we're just going to play with the GeoBoard. Hello, Nicole. So if you haven't already noticed, Nicole, there's a whole bunch of stuff in our course, 2nd section from the top. And we are playing with the GeoBoard app right now, which will lead us into activity 14.1.
Okay.
All right, so the assumption we're going to make here is that the distance horizontally or vertically between each peg is 1 unit. Okay. So if I were to drag an elastic on here and then stretch it over, I've just made a square. What's the area of my square?
1.
1 unit, right? Okay, so that's good to know. And then I can easily make, oops, a new one. And I can make an area of, how many? 2. And this is kind of fun here because it's got a little tool here where I can draw on here. I can do the free form draw stuff, and I can erase it. And I can also draw lines. So if I wanted to demonstrate something, pick a different color. Oh, right. I can break that up there without grabbing another elastic and say, hey, look, there's 1 square and another square, so this is 2 squares. All right. So one note about the stuff we're doing is, as far as area is concerned, pens. There we are. Typical measurement for area is squares. Now, it turns out you don't have to use squares. You can use any shape that will just tile together, kind of like floor tiles. Okay? Could be triangles. Could be hexagons. We tend to use squares, okay? And that's okay. In terms of units, instead of just calling them squares, we have things like square centimeters, square inches, square feet, square kilometers. And I'm just going to pick on the square centimeters for a moment. Literally, it is 1 centimeter by 1 centimeter square. Our best artistic rendering of a square today. Do you know any other units of area measure that we use that are kind of different than square inches or square centimeters, square feet, or square kilometers?
Square miles.
Square miles is like square kilometers, yeah, so that's pretty close.
Acres?
Acres, yeah. Acres is kind of a different idea. And does anybody know the metric idea that's like an acre? It's called a hectare. And so acres and hectares, they're measures of area, whereas a kilometer is a linear measure turned into an area measure by going 1 kilometer by 1 kilometer perpendicular. Right? So we wouldn't ever say square acres. That wouldn't make sense. An acre is a certain number of square miles or square feet. We wouldn't say a square hectare because a hectare is a certain number of square kilometers. Okay? So that's a different kind of area unit that we have to get used to. So some areas measured in squares, other times we use special measures like hectares or acres. And we'll come back to that. Question?
Is a hectare like
No, a hectare actually, it's usually in kilometers, and I think it is it 10 kilometers by 10 kilometers? Yeah, look it up. I don't use hectares very much. And there's also a smaller version of a hectare called an air. You just take the hect off and you get air. It looks like A-R-E-R, but it's air. So hectare. It is 100 meters by 100 meters is what a hectare is. It was just here and then it went away. So here it is. It's 10,000 meters squared. And if we break that down, the 10,000 can be written as 100 times 100. And meters squared is really meters times meters. So it's a region that's 100 meters by 100 meters.
So
Okay,
one
so I was way
acre
off.
would be 100 meters squared?
No, an acre is what, like, I used
It
to know
says
what
it's
an acre
100
was.
acres is a hectare.
No, that was an air. It said 100
Oh,
airs,
I'm
which looks like acre, but it's just
Yeah, I
ARA.
can't
It's just,
see
yeah, it doesn't have the
where
C in there. So you're referring to, where do they have that?
right up there, like right.
Yeah, it says not
Okay, I see now, yeah.
airs, not acres. Yeah, and very few people use airs. So I don't even want to talk about them. They're in the book, but they're very rarely used. Let's see, what's an acre? An acre is 4,840 square yards, which I think, if I remember, is that 640 times 640? Where the heck that came from, I have no idea. 640 squared. Oh no, that's way too big. 64 squared, maybe? How do I think? No, that's not it either. Okay. Let's go to Wikipedia. They usually have good things. Oh, it's 1/640th of a square mile. Okay, that's where I get the 640 from. Yeah, 43,560 square feet. So they're kind of good things to know, and we'll play around with some scale drawings of those later. But at the moment, I just want to go over some basic stuff. But units of measure are important. For now, with the geoboards, we're just going to talk about squares. How many squares is it? All right, so back to my geoboard. Let's go. All right, so here's what I'd like you to do is, can you make me a polygon? Make 3 different polygons that have an area of 2.5. And for those of you using this online geoboard, at the bottom, there's the little geoboard and the bigger geoboard. Let's switch to the bigger one. Let's grab a, whoa, what'd I do? Messed that up somehow. Oh, I'm still on the pen. That's right. All right. Just very clear somewhere. Let's clear that. So we're going to make 3 different ones that are, there we go, 2.5. So I know how to make a rectangle that's 2, and I change it to something that's just a little bit bigger. This one is 3. I need it kind of right in between there. So this red one would be one example of 1, 2.5.
You said 3?
What's that?
You said 3.
Make 3 different ones that are 2.5. Yeah. I think I have 3 different ones. I'll try to justify them in a minute. Hopefully you have something different than me. Whoa.
I don't know if I did right, but I got something.
I'm going to try and copy one of yours. Let's see. Let's try. I have green. That's all right. Go here, and there, there. Let's move you over. Do that evenly. You go there. You go there. Here. Here. Let's go straight down there. I think that's one you made. Okay. Anybody want to come try to draw one on my little tool thing here? Not really. What's that? You're messing up?
Yeah.
Just try
That
something.
is 2.5, right? I can count, correct?
Yeah.
Okay.
All right, so I'm gonna, yeah, so here's some ways to kind of figure it out here. So I'm gonna draw on the screen. Where's the pen? And it's trial and error. So this one right here, 1, 2, I tried to make it come this way. That was too much, so I just backed off. And if I cut a triangle through the square, I get 1/2 a unit, right? So there's 1, 2.5 there. Now this one right here cuts in half a rectangle. I draw the rest of the rectangle in right here. So what's the area of this rectangle if I take the red and the purple together? 1, 2, 3, 4. It's 5. And what happens if we cut 5 in half? What do we get? 2.5. So that's what I was thinking about there. I took a rectangle and I cut it in half. So this purple thing must be 2.5. And on these things, you can, there's a color button here somewhere. So if I click on that guy and then I say color you in, I can kind of shade the area. All right, this one here is a wee bit trickier. So I just want to draw what I was thinking on that one. Pen. All right. So I was imagining this square here that's 2 by 2. So a square that's 2 by 2 has an area of what? 1, 2, 3, 4. Okay. So this little p triangle off here, I'm missing, right? How much area is there? So I lost 1/2. Okay. Then the question is, how much did I lose up here? Well, you could say that's part of a 2 by 2, a 1 by 2 rectangle. And so that had 2 square units. I only have 1/2 of it. So how much is up here in the corner? 1. So I lost 1.5 to get the green region right there. So 4 minus 1 is 3, minus 1/2 again gives me, yeah, I'm pretty sure that's 2.5 there. Okay. So I've made, so there's 2 different ways you can try and glean an area from one of these things. You could encase it in a larger square or rectangle kind of thing and chop pieces off. or you can dissect it internally. So I'm going to do that next. And it's a matter of just playing around. So internally on this one, if I chop it right there and then come across there, I can see I have an area of 1 right there. I have an area of a half right there. And then what's this triangle right here? It's 1. So there's 1, 2, and a half. Okay, so I'm going to do that with this one over here. I'm going to break it up. So here's 1 whole area. There's 2 halves here, which is another whole, and there's a half up there. So yeah, there's 1, 2, and a half up there. All right, so what I'd like you to do is play around, come up with at least 2 other different ones.
Are we?
Yeah, so, okay, so for this activity, it says do 10. I found 10 excessive. So we're going to back it off to 5 or more of each type. So,
And same with the bottom ones.
yeah, so I made a note up here for each. So we're going to do this 3 different times for 2.5, 3, and 3.5 for areas. And for each time, we want to come up with at least 5 different ones. Okay, so finish up the 2.5 one, and you want to document this eventually on your dot paper. So usually what I do is I play with a real geo board or the virtual one, and then I draw it out on dot paper. If I do it directly on dot paper, I'm erasing and erasing and erasing, scribbling things out constantly, which is a little annoying. So just kind of play around there.
If we can fit more than 1 on a little block, can we put more than 1?
Yeah, you can put as many as you can fit in there. Yeah. And as far as those of you that aren't with me on campus, I have a link to some dot paper here, which is, this looks like a 0.5 centimeter grid, which may be too many dots, but oh well, we'll go with it. So that's where you can document your work. Yeah, so where it says 10 or more, we're just going to do 5 or more. So build those, document them, and then we'll talk about them a little bit more. Oops, like that.
Still doing 2.5.
Yeah, so we want to come up with 5, at least 5 different 2.5s total. So just kind of mess around, see what you can come up with. And once you get enough 2.5s, move on and try and make some size 3 ones.
Three or three?
We're going to do 3 and then 3.5. Get that right. Let's see. Yes, 3 and then 3.5.
We going back to
3.5.
just
Yeah, so we want to come up with at least 5 of each, 2.5, 3, and 3.5. So we'll start comparing notes with each other in just a moment. getting any easier as you move along?
Oh,
A little bit. You start learning some tricks as you play around. All right, so in just a minute, we'll go over some observations about these.
Just a key list of convex versus concave, you can draw diagonal shape.
It's so if all of the diagonals live inside, it's convex. Any diagonal that's outside, it's concave. So if we look at my shapes here, the first three here, any diagonal that I draw is going to live inside of the shape. With this green one right here, there's one diagonal that is outside of the shape, so that means this must be concave. So convex, 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 concave. Here, although this diagonal right here would be inside, there's a diagonal outside. And a diagonal is just connecting any two vertices that are already connected. Yeah, so I have three convex polygons, and I have 1, 2, 3 concave ones. All right, so let's take a look at a few of these. So I'm going to go back to, let's see, my areas of 2. Let's see, we did 2.5. Let's go on to 3. So here's some of my 3s here. 2 questions. 1, are they all different? And 2, are they really all 3? Are there any that are questionable to you?
The yellow triangle?
This yellow triangle right here?
No.
No.
The other yellow triangle?
This orange one?
Yeah.
Okay. That is, let's see, what does it measure? It goes 1, 2, 3 across the bottom. So if I encase it in a, let's get a pen out, line tool, in a square. So this square is 3 by 2, so the total area is 6. So I have half of that.
Okay.
So that should be 3.
Okay.
The kite. Okay, let's check out the kite. All right, let's switch colors. So the kite, I'm going to do that breaking it up internally. So I'm going to cut it right there, and I'm going to cut it across right here. So I could flip this triangle over on top of that one, or right next to that one over here, and I would get an area of 1 right here. And then if I take these 2 lower triangles and stick them together, they would fit inside this rectangle right here. And again, if I flip this, rotate that one over, and I put it over here, so I can basically repackage the kite into a rectangle. You see that? And what's the area of my yellow rectangles combined? 1, 2, 3. Yeah, so it does have an area of 3. Does that make sense?
Yep.
Okay. How about this one over here? It's part of a rectangle that measures 1, 2, 3 by 2. It's half of it, so half of 6 is 3. Is it different from my orange one, though, or are they really the same triangle? Yeah, so congruent means we can take one shape and pick it up and put it on top of the other, and it'll be a perfect match. So I would say this is congruent. Now, one problem with this is, oh no, I guess I can just rotate it. What? Will it rotate? Sometimes it's hard to picture. This tool has a place to do that. Where am I? All right, so I think I can make a copy. Oh, what did I do? No. Okay, there you go. I can duplicate that And then I can rotate it.
You'd have to rotate and flip it.
Yeah, so this needs a rotate and a flip. There we go. And then I can grab it and sit it right on top. Yeah. Oops, I missed a little bit. Yeah, so they're congruent. They sit right on top of each other. How about this green one? Do you believe it's 3?
Yeah.
Because I made it. I make mistakes every day. So let's make sure I didn't make a mistake here. So if I try to cut this one internally, oh, I might be able to do that. But I think I'm not going to. Let's get rid of that. I think I'm going to do this externally. So if I encase this in a rectangle, and then what I want to do is get rid of stuff from that rectangle. So let's see. There's a triangle up here that measures 1, 2, 3, 4 by 1. So what's its area if it's 4 by 1 is a triangle? Half of a rectangle. Half of 4 is 2. Yeah, so this right here, I get to take away 2. But what am I taking it away from? The whole thing is 4 by 8. Okay. So starting with 8. Ooh, that's not a very good color. 8. We get to take away 2 there. That gives us 6. All right. Down here, this is what? It's half of a 2 by 1 rectangle. So I get to take away 1. That takes me down to 5. And then over here, what do we got? This is 2 by 2. 2 times 2 is 4. I want half of that, which is 2. So if I take away 2, what's that leave me?
3.
3, is that what it's supposed to be? Yeah, we're in the 3 page, yeah, so I'm okay. And that one took me a few tries to get it right. First, I had this bottom point over here, and that didn't work. Then I moved it way over here, and that didn't work. Then finally, I backed it up and put it there, and I was like, oh, there we go. I was too big over here, I was too small over there, and just right in the middle. It's kind of interesting. All right, questions. Anybody have something wild they want to show?
All of mine.
All of yours? You want to come? You come draw one up
Oh
here.
my gosh.
Yeah, you can do it. Come on. All right, so let's see. Is this my 3 page here? Yeah. Can you fit one on here, or do you need a new page?
I think I can fit.
Okay.
Which one you want? They're all pretty.
You pick. What's your favorite? So you grab the elastic and drag it up. You gotta grab it and drag it. Yeah, and then drop it. Yeah. And then you can move. And if you grab in the middle, you can make new connections. Yeah, there you go. Yeah, it takes all getting used to.
Here. This one. Trying to follow my directions is interesting.
It's different using this than real elastic.
Here.
Ooh, that's wicked cool.
It's
Okay,
like
let's-
round.
I know.
it does look like a crown. Okay, let's test this sucker out. So I'm going to bring this into my screen. So I can draw on it here, can't I? I have drawing tools right there. And switch to, let's try yellow. Okay, so let's see. I think we can cut straight across there and maybe cut down here too. Yeah, so this is, you could consider this right here part of a 2 by 1 rectangle. So it's half of that. So there's 1 in here. Let's switch pens. So we got 1 right there. And so this would be another 1. This would be a half right there. And another 1/2 over here. So altogether they get 1, 2, 3. Yeah, nice. Cool. All right. Anybody else want to try and draw one up here? Taylor? Not yet? Maybe later when we're not recording on video. That's kind of high pressure, isn't it? All right. So I got some other ones. Let's see. Let's go to my 3.5 page. Okay. So I started real simple. I just started making a rectangle that was 3 and then threw on an extra half triangle right here. Let's see. This one over here that idea came from me messing up over here. I accidentally made that one that was 3.5 before I made my 3. So let's just double check if I did that right. Let's see. So now I can't dissect this one internally. Can you guys see why? That doesn't hit at a point. So I have no idea where they're meeting, those two lines. So that's not going to work. So sometimes you can't dissect things internally easily. So this one, I'm going to go for external. I'm going to encase it in a rectangle. And then start chopping stuff off. So what do we have here? 1, 2, 3, 4 by 2. So I started off with 8. And then from 8, we got to start subtracting stuff. So let's see. This right here is 4 by 1. If the triangle measures 4 by 1, what's its area? 2. So I'm going to lose 2 there. So I'm going to minus 2 right there. This one over here, let's see, let's do this one. This is 2 by 1. What's half of that? 1. So I get to minus a 1. And then what's this one right here? This is 1 by 3, which would be 1.5. I get to lose 1.5. So 8, 7, 6, 5, 4, 3.5. Yeah, I did it. And then I just kind of started playing around. Like this one over here, I had actually started off with a 1 by 2 rectangle, and then I started adding a half a unit at a time. I threw a half up there, and a half over there, and a half over there. So that I started off with switch pens, 1, another 1 there, and then I started adding halves. So 1, 2, 3.5, and that one right there. All right, anybody have one they want to demonstrate up here? Emily, you want to try? Okay. Yeah, see if you can build one of your 3.5s, and I can give us a new screen pretty soon. This might crash my computer, but it's still going. Yeah, so the way it works is you drag an elastic up. If you drag an end point, it repositions it to get a new point. You click in the middle somewhere.
Oops.
You can just readjust mine.
Okay.
Let's move the points around.
Sorry.
That's okay.
Here. How do you get another one? You just
Click in the middle somewhere, and that'll give you a new goal to grab. Put on.
I'll try one after.
You try one after her? Oh, good.
I don't know if it's right.
no.
Which one? I can take a look.
I'm gonna start with
No, right there.
It's kind of confusing, isn't it?
yeah. Okay. Let's start with
Have to find an easier way to look at it.
another.
Yeah, start over.
Yeah. Wait. This is not easy.
No, it takes some getting used to.
Okay, and if I
I
go
sat around this
here
for an hour before this playing with it.
and I go ooh.
Click in the middle there.
Good.
1, 2, 3.5. Yeah, 3.5. Whew. Okay. All right, so your turn.
Mine's so simple compared to yours. You're shaking it.
Yeah, so go down at the bottom and grab an elastic and drag it above. Click and drag. Yeah, hold on to it. There you go. And then drop it somewhere. On a pin. Okay. And then you can start moving things around. So to get a new part of the elastic, click in the middle.
Oh.
And then pull. Yeah, that gives you a new pin to drag to. right, so we got 1, 2, 3. All right, hello, 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 world. I'm going to finish this recording. Hopefully we didn't lose much. Okay, so double checking here. Let's see, drawing some lines, yellow. Oops, no. I want to draw, what happened? There we go. All right, so there's, I think I'm going to chop this into a bunch of halves. All right, so we have 1, 2, 3, 4, 5, 6, 7 halves. Half of 7 is, on a good day, 3.5. Yep, so it works, that's what we want. Up here, let's see, we can break this into 1, 2, 3.5. Yep, very nice. All right, we're on a roll. Okay, so before we answer some of those questions, I want to show you another set of drawings I did somewhere here. Ah, here we go. Each of these figures has something in common. They're all triangles. Okay, they have something else in common. Their area, okay. Let's guess what the area might be. What is it? 2.5? Yeah, it's 2.5. Yeah, so up here, if we go across 1, 2, 3, 4, 5 across. So this is part of a rectangle. That's 5 units, and we have half of that rectangle. Oops. Try that again. So we're half of that rectangle right there. Yeah, so this has an area of 2.5. It's triangle. All right, what about this one down here? Claim. Ashley's shaking her head. Yeah, it's 2.5 too. So a couple ways to think about it. This is 5 by 1, so it's a 5-unit rectangle, 5-square rectangle. And over here, I cut off how much? If I consider a 4 by 1 rectangle, I have half of it. I lost 2 over here, and then I lost how much over here? Half. So if we take 5 and take away 2.5, we still have 2.5. All right, let's go down here. Encase this in a rectangle. All right, this rectangle was 6 by 1. So it had 6 units in it. I'm chopping off a chunk down here. That's how much? Let's see, that goes across 5 by 1. So I lost how much down here? I lost 2.5 down there. Yeah. And how much am I losing here? Oh, wait, no, that's 6. I'm sorry, that's 6 by 1. So I lost 3 over here. And I lost a half over there. 6 minus 3.5 is 2.5. So my triangle still has 2.5. All right, this one down here is crazy. I'm going to encase it in a rectangle and see what we got. All right, so question, how long is this rectangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 by 1. So from 10, we're going to take away some chunks. How far across does the bottom triangle go? It goes across 10. So it's 1 tall. So what's the area of that bottom triangle? So it's 5. So I just lost 5. So I have 5 remaining. This upper triangle right here, upper right, is how far across here? 5 by 1. So I'm losing 2.5. So from 10, if I take away 5, then 2.5, what's left? Okay, so I just want to summarize what these suckers have in common. And we're going to make an observation based on that. So these are them right there. So things that are in common here. These are all triangles. Oops, need a better color. These are all triangles. They all have the same area. Area equals 2.5. What else do they have in common? They have other things in common we haven't mentioned.
They're not all obtuse triangles.
Okay, that's what they don't have in common. What do they have in common, though? They have two other features in common, at least.
They're all three. Oh, I guess that's true.
They're all three-sided. Yeah, we got that. Okay, cool. That's all right.
They all have at least two acute angles.
They all have at least two acute angles. Let's see. Acute, 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 acute. Yeah, they all have at least two acute angles. That's not what I was thinking of, but that's cool. At least two acute angles.
Do they all have the same perimeter?
Ooh, no. They don't have all the
I
same
don't
perimeter,
remember
but
perimeter.
they have one side in common.
Oh, one length is all the same on one side.
They all have one length that is exactly 5. Okay, so we have a length that is 5. Now, length and height, that always confuses, length and width always confuse me. I like to call them base and height. So flip these over. I'm going to call that length a base instead. What usually goes with base? Base and height usually go together. Okay, so if this side right here is considered the base of the triangle, how do you find a height? Yeah, height, you use that as a baseline, and then you go perpendicular from a point off that line back to the line, and you get your height. So if that 5 is the base, what's the height of this bottom triangle? It's 1. What's the height of this triangle right here? 1. What's the height of this triangle right here? What's the height of this triangle right here? 1. So turns out you can play around on a geoboard with this with kids. As long as the triangle has the same base and the same height, they have the same area. So that gives us the way to find the area. So in this case, if we take a base of 5 and multiply it by a height of 1, well, that gives us 5. What's the area supposed to be on these guys? 2.5. But then we go back and say, well, each of these triangles could be recut to be half of this rectangle. So that means what I want to do with my formula is take half of base times height. So that gives us the area, experimentally, of a triangle. It has to be, and there's a couple ways to look at it. You could say base times height divided by 2, or some people like to say 1/2 of the base times the height. There's many ways to phrase it, but they all give us the exact same result.
That's the one. Correct.
This is only for triangles, correct? Yeah, so what the next few activities we're going to do are going to help us tease out these formulas about some polygons. I'm going to stop this broadcast and we'll start a new